The conversation is so good. I hate to say we're kind of in the final lap, final session panel here. It is interesting. I was just back. I noticed that we had the Netherlands delegation in the back. And I was asking them if they were just here to be out of the office or if they were learning something. And they actually told me that the problems we're discussing, forecasting, parts, materials, all the kind of stuff, is exactly what they're faced with as well. And so it's not news. It's not just to the U.S. So it's a big problem that we're all going to have to address. Now, what we are fortunate about, and if you wonder why I'm doing this turning around, these are my glasses. And when the arm falls off your glasses, you can put it on and it looks really stupid, and then people would think I was John Riggs, or you can leave them off, and people won't do that. Anyway, our final panel today is being hosted and forecasted by Scott Harris. Scott's the product support manager of the Aviation Turbine Engine Project Office. And that's an interesting thing in and of itself, because engines used to be handled underneath the MDS platforms, and what they found is that as we go forward, they needed to have an office dedicated to the engine. Now, I challenge Scott each time I see him and say he needs to expand that to the powertrain, because we build engines and then we are transmission limited, or we're gearbox limited, or we're rotor limited, or we do the same thing with another component and it flushes itself through the system. So, Scott, I'm still pushing that message. So, I'm trying to make your office bigger is what I'm trying to do.
There you go.
Okay, but he's here on behalf of General Todd, who, of course, you know is with the AMC commander like everybody else, going through a number of things. And a matter of fact, Colonel Atkins, when you get a chance, thank her, because she was summoned to be there too, but has been allowed to be here, and she is going to get on a plane tonight so she can be there first thing in the morning to answer her parts of the questions. So again, thank you so much. So Scott, if you would introduce your panel, and this is going to be a great opportunity to hear from some professionals.
Well, thank you, sir. I do want to say a couple things here. So Colonel Atkins wasn't lying. That is one bright light. And then, as just as an opener, so yesterday, you get a chance to come to these events and you see a lot of old friends and such. So I was sitting at lunch yesterday, and I've always thought of myself as a pretty young guy. But one of my good friends reminded me that everything we flew is now on a stick. So I guess I'm getting up there. But on behalf of General Todd, it's a pleasure of mine to sit on this and moderate the panel for PEO Aviation. Those of you know that our mission is to serve soldiers in the nation by designing, developing, delivering, and supporting advanced systems and capabilities for operational commanders and our allies. And General Todd has established, his vision going forward is that we're doing that through providing integrated sets of capabilities to cabs in order to give the operational commander greater reach, reliability, and lethality. Today I'm representing Colonel Kirkendall in PM ATE, Aviation Turbine Engines. To my right, I've got Colonel Steve Clark, who's the PM for Future Vertical Lift. He's a Master Army Aviator, Naval Test Pilot graduate. He was a Special Operations Aviation, he was a product manager for the MH-60M. He's been a project manager for Fixed Wing, Non-Standard Rotary Wing Office, and now the Senior Acquisition Advisor for the FVL CFT, in addition to being the PM for the FVL. To his right, we have Lieutenant Colonel Andy Deuce. He's the product manager for the UH-60 Victor program. He in the Utility Project Management Office. He is a UH-60 Alpha and Lima MTP with operational experience in maintenance and logistics. He's a graduate of the U.S. Military Academy and holds a MBA from UAH. He's acquisition course since 2008 and level 3 program management. And then to his right, we have Mr. Tim Sweeney, who's the Portfolio Product Support Manager for Apache Project Office. He's retired Army National Guard officer with over 30 years combined logistics experience. He holds a Master's in Science in Logistics from FIT. He's DIWEA certified in Lifecycle Logistics. He's also a Senior Service College graduate and a member of the Acquisition Corps. So within, as General Munt was explaining, General Todd had the vision to move forward and define, based on his experience over in the Utility Project Office, of understanding that engines require some intensive management and looking forward to a strategy on how you match power capability to platforms in the future. And so he established in this year, in February of this year, we established a combined aviation turbine engine office that took on the mission of not only the ACAT 1C program for ITEP, but also the management of the T55 and T700. And as General Muntz has indicated, we're looking at other opportunities, evaluating as we make a strategic effort forward on how we would consolidate and bring on more capabilities associated with power generation. But what we don't want to do is lean forward too fast before we understand how to best manage that activity. Okay. So that office that I explained is Colonel Roger Kirkendall is the project manager. His deputy is Bob Shibley. And so within the office right now, we have the two major product lines, which the ACAT 1C for improved turbine engine, and then we have a second product office that we've stood up with a product lead, Miss Kimberly Baker, she changed her name, that's managing that. We've also established, we brought in to get an integrated project office. We have on-site ACC Redstone and an ALC in order to manage that entire lifecycle component and to give us a better acquisition capability. Okay. So that portfolio that we're managing includes, like I said, the ITEP engine, which is a class replacement engine for the T700 in the future. And so we've recognized that the T700 has been in service since the 1970s. It's been modified and continued to move forward, and it's performing great, but it's meeting the end of that improvement capability. And so the Army leaned forward and looked at development of a new engine in order to get us the class power required to lift the AH-64 Echoes, the UH-60 Mikes, UH-60 Victors, and then what may become the FEL-CS-1 as requirements in the 3,000 shaft horsepower range. Okay. Right now, the status of that program, I'll talk a little bit more on the next slide of where we stand in the path forward to get it to a qualified capability out to the field. You can see from the numbers that we manage. From the T700 to the ITEP, you're looking at about 6,000 engines in circulation in order to manage that program, and then just right at around 1,000 to support the T55 CH-47 fleet. Okay. So ITEP in itself, it's an ACAT 1C program. We are pre-milestone B. That program, like I said, was to move and bring forward the limitations on the 701D platform to support the H-60 and H-64. A lot of folks get wrapped around the increase in power. The shaft horsepower is a raw component. And the interesting thing you have to think about there is that we're really trying to achieve 6K95 power for those two platforms. And so there's an altitude lapse rate associated with the engine that allows, and so the target we're looking for is greater than 1760 horsepower at 6K95. And so there's not an intent to drive in and cause a lot of, powertrain integration requirements for the aircraft and other things. It's to have that capability. And if you look at really kind of the growth of the T700, it's gone from 1,600 to 2,000 shaft horsepower within those same type of platforms. And so in each case, it was to get and respond to greater operational environments, effects of density altitude, growth of platform weight. And so as you can see on there, the 701D in 2003 timeline is as they were limited now in meeting their mission to a 6K95 mission is only being able to carry 5 packs or, having a FARP every 200 kilometers. And so what the ITEP gains them is the ability to carry that full mission load to achieve that mission at the high altitude environments or high density altitude environments. Okay. So the program status right now for ITEP is that it was a science and technology program that transferred over. It was advanced affordable turbine engine, put forward the intent to look at hardware opportunities and advancements that would provide better fuel efficiency, better power to weight ratio, higher reliability, and increases in some of the things that, from a reliability standpoint of what was hampering current engines was sand and dust environments. So improved particle separation was a big component of the AATE program. So out of that program, there was we established the ITEP and awarded a competitive TMRR contract down to 2 vendors. And those 2 vendors were to Advanced Turbine Engine Company, which is a joint venture or a partnership between Pratt & Whitney and Honeywell, and General Electric, to basically plan out and provide a preliminary design review for their products to meet this objective. And so during the TMR, we did several trades analyses to include the supportability trades were a big component of that. And so in those supportability trades, we looked at things like human systems integration and maintainability analysis, looked at advancements in gaining greater availability. And we've also been leaning very far forward during this phase of the program to look at our depot maintenance support planning. And been reaching out to CCAD, even though we do formally still have to do a formal DSOR as part of the program, which we will do in EMD once we down select. But we understand that CCAD is a center of industrial technical excellence for aviation turbine engines, and so we've been here, discussing a lot of how that transition would go, what needs to be required, and we shaped a lot of what was in the EMD RFP based on those engagements and early planning. Like I said, on the schedule-wise, we're completing that TMRR effort. We released back in the beginning of summer, May, we released an RFP for actually it's been a year ago, RFP. We released the RFP for the EMD phase, and we're expecting an opportunity that we'll seek milestone B in late January in a first quarter of our second quarter of calendar year 19 contract award, which at that point will down select to a single vendor that we will take forward to through critical design review and integration into the 2 stated platforms, the UH-60 Mike and the AH-64 Echo. As I said, additionally, we have the T700 engine that's out there. It's very successful in meeting its requirements today. As we've cycled through the different models, there's been an intent to try to drive through and get more pure fleets. So currently, earlier this year, we drove the last of the 701 or T700s out of the fleet. We're now, removing down to the last of the T701 Charlies, and those are distributed across all 3 compos, not limited to just one. But that number is down below 180 now today. And so most of the fleet is operating the -701D engine. Now there's a combination of controls that can meet up with that based on whether, what platform it's installed in and such, but we're trying to get to a common control system as much as achieving the pure fleet of the 701D. The office is working through several CIP programs to try to continue to improve. The biggest thing with any, is that we can't focus all of our attention towards the acquisition of new products because we recognize it's going to take a considerable amount of time to field all of that. So we've taken a lot of time to look at how can we continue to maintain the current engine throughout that life cycle until it goes through its final disposal. So we're devoting a lot of attention towards the reliability, continued maintainability improvements, and such to afford better supportability out of the engine. And some of those may include, we've done CSI updates to ensure better tracking of parts, including of marking of IUID in order to get better asset visibility. Some EDECU, with electronic components, you're constantly looking at DMSMS and effects of, end of life on electronic circuits. And so we maintain a lot of visibility on that in order to ensure that we're ahead of the game on those components. And then, looking at reliability improvements and the ability, maintainability improvements for repairs through actions like cold spray on the compressor and such. And then as far as the T55, the same type of components, the engine is performing very well out there. In fact, we're looking at several areas where we've increased at least once the time between overhaul on the engine, and the next we're getting ready to undergo a second study to look to see if we can extend it even further from that line in order to get more time on wing. There's several improvements within the fuel controls, the HMA, and looking also at different ways to address erosion in the field. All of those activities is an intent to either improve reliability, availability, or maintainability in some fashion or feature. Okay. And I'll pass it on to Colonel Clark.
Thank you, Scott. I'd offer today that the future of Army aviation is on the cusp of a stepwise increase in fleet-wide capabilities. But I'll caveat with, so long as we don't fumble the sustainment football. To back that statement up, I would look at what do we see in the environment that is either enabling this statement or not. You could argue that the physics of aero haven't changed. We're still applying the Navier-Stokes equations. But what has fundamentally changed, in my opinion, since our last attempts in the 80s, 90s, and even the early 2000s, is access to high-performance computing, and when merged with manufacturing technology, such as additive manufacturing, as mentioned otherwise, we're able to now fully exploit those equations and to achieve exotic layups of materials, novel designs that address the full complexities of the aero environment. Not only to achieve a material outcome, but to do so in a repeatable fashion, which has always been a challenge for us as we've tried to stretch the bounds of rotary wing aviation. I would also offer that we're starting to transition from years of just data collection associated with condition-based maintenance. And at one point, we were looking to put a sensor on every rotating component. We're much more informed now. Now we know how to deal with big data, but we're also realizing that we don't need the gross number of sensors that we previously needed. We're able to approach it from a more informed position to increase maintenance intervals. And then there's the advent of what we've been saying in future vertical lift of the digital thread. The ability to take digital design tools through model-based systems engineering, translate those through from design to manufacturing into the supply base that may be distributed. It is a global distribution. Bring that back together to produce an aircraft with minimal tolerances. we've almost eliminated the need for the old inefficiencies of the manual red line drawings going to and work release instructions going to the assembly line. When General Yellen and I had worked together on the MH-60M production line, we would model, if we were going to be on time in our deliveries, with two simple metrics that were very difficult to finally achieve, and that was worker efficiency and scrap and rework. If we knew we had the right number of workers showing up that were trained, and we modeled their scrap and rework, we kind of could then determine what the outcome was going to be and translate that to an on-time delivery. With the advent of digital thread, I will offer that we should be able to nearly eliminate scrap and rework. We're starting to see evidence of that today in joint multi-role technology demonstrator aircraft. And then we would need to look at resources, because it's one thing to have all these great ideas and to have access to these new tools, but if you can't resource the program, you may not realize what you're trying to do from an outcome. If you look at the modernization of the current fleet, arguably we've never been in a better position, in my opinion, in Army aviation. I believe we could argue with strength that we have the world's greatest attack aircraft, assault aircraft, and cargo aircraft. That puts us in a strong position from a resourcing perspective to focus on the future. And finally, the strategic environment. As we look at emerging language since 2016 out of Congress and NDAA language, they are spurring us on to be more agile in our acquisition. They're giving us additional tools through these OTAP type contracts, middle tier authorities, et cetera, to enable us. Couple that with just over a year ago, Chief of Staff of the Army and Secretary of the Army announcing that future vertical lift was the #3 Army priority. And the stand-up of Army Futures Command is creating an environment that is ripe with opportunities for us to break the traditional 15-year development cycle. I've never seen it better, so we have to capitalize on it. What could go wrong? Well, I would say if we were to create an enduring capability in future vertical lift, it was mentioned earlier, build 50-year platforms. We must begin with the end in mind, especially across all sustainment pillars. My only caution is that we must guard against applying current generation thinking to next generation needs. What do I mean by that? And I'll try to tread lightly, because our tendencies, our best practices historically have been, if I want to develop a maintenance working group or a cockpit working group, I immediately go find the graybeard. Who's the senior enlisted maintainer? Who's the CW5 who has all that knowledge basis? And assemble them together to start looking at how would we maintain the aircraft of the future. I would argue that we may need to modify that thinking and look to younger generations. I know certainly within my project office, when we start talking about the cyber domain, I don't have any gray beards. They're young. They're very young, and they're innovative, and they're creative, and similar with some of the other approaches that we have seen. So beginning with the end in mind, certainly we see the operational environment, and TRADOC is doing a phenomenal job, I think, of describing and defining the multi-domain battlefield and the complexities that we will see in the future fights. That logically drives our maintenance concepts. We envision minimal maintenance forward, increased durations of maintenance-free operating periods with respect to scheduled maintenance. Well, certainly that implies a need for designing ultra-reliable systems and subsystems that employ adaptation and graceful degradation in their systems, in their fault trees. And then we have to exploit the advent of autonomous flight. That opens up a new area for us to be able to evacuate aircraft autonomous, in an autonomous nature, to relative areas of sanctuary that we can't do the maintenance far forward, and then bring them back. We see emerging technologies. I mentioned earlier, as mentioned in the previous panel, on additive manufacturing. 5 years ago, I was probably a naysayer and saying, hey, it has limited application from models, but the structural integrity and how you qualify that and repeat it is in question. That has rapidly been changing. I've had the good fortune of being out in industry and seeing some of the additive manufacturing applications, and I'm very encouraged for that. But more so from not only just a manufacturing standpoint, but think of the implications to our sustainment and logistics tails in the field. Are we that far, if we look at 2030s on, from going to the PLL clerk and as opposed to having multiple ISU 90s lined up, they may have an additive manufacturing capability for non-flight critical parts. That's pretty remarkable in my mind, but it certainly is the way that we need to approach this. And how great it would be. My number one concern when I was associated with the lifecycle management of the 160th aviation assets was not meeting time on wing or time between overhaul. It was corrosion. That was what was one of my limiting factors, and oftentimes it was on the shelf in the PLL clerk. We didn't have enough storage area, so we would take GG rotors out of their box from the manufacturer and store them, only to find that they corroded. We may be able to change that dynamic with the advent of these capabilities. I also looked at what technologies are we applying that could reduce our calibrations burden. Do we really need torque wrenches in the future? I'd like to think a simple analogy is, when's the last time you over-tightened your gas cap on your car? You turn it until it clicks once and you stop. It's good enough. I don't know that we may get there, and I don't necessarily think that we need to look at the old torque-to-yield bolts that you see often involved in the automotive industry today. But certainly, torque sticks may come into application. If any of you enjoy maintaining your own automobiles, there's some automobiles we see out there, especially from the Asian auto industry, that bolt sizes are pretty well standardized. There's a minimum number of them, and the torques are pretty well standardized. That may make something like this applicable for our future as well. The area I'd really like to focus on today, to some extent, at least to pique your interest, is the next generation aviator and maintainer. What does the recruit or new aviator look like in 2030? Arguably, it's not the demographic represented by us in this room today. What's their basis of knowledge and experience when they show up? You could think of it as simply from a man-machine interface. Do we have the need for typical control layout like we see today? Or do they just interact with the environment? I often, am amazed at my 16-year-old son. He has little inclination to want to drive because he says devoting that much attention to one function is boring to him. He wants to interact with the environment through supervised autonomy. We have to think like that, in my opinion, as we move forward in future vertical lift. It may no longer be that the aviator of the future is the exceptional stick and rudder pilot whose skill set, but it's more of a mission manager and can interact with that environment and understand it. What will be the need for tech pubs in the future? Any of you who have younger, either kids or grandkids, I would challenge you to find an operator's manual associated with any of their gaming systems today. But yet, they will fall in on an Xbox controller with multifunctional capabilities and interact in an environment that just absolutely blows my mind without a single piece of instruction. And I often say, how did you figure out how to unlock whatever? And they will really tell me it's through crowdsourced learning. They'll go to YouTube or some chat group, and they're interacting with design engineers, et cetera, and figuring out how to access these functions. So should we be focused on items or some different methodology? I once was, I think it's the last quad A, I had my son there, and I was showing him one of the aircraft and the checklist associated with the aircraft. I was quite proud of myself for informing him that at one point I had that memorized. I don't know, it was a lot of steps. He was thoroughly unimpressed. He said, "Why don't you just push a button like you start your car? And it tells you if all systems are go and working normally." He found absolutely zero need to remember or commit to memory multiple steps to tell him the system was working. I have been encouraged in looking at the training and synthetic training environment. What we see today is the advent of maybe some more like VR type applications that transition away from having to have just steps, the old reductionist thinking of how to outline all the steps associated with removing a gearbox, and being able to put on a set of VR goggles and look at the gearbox and it walk me through all of the steps associated with doing that. I definitely think that that is an area we must continue to exploit and move forward. So in closing, I couldn't find a better venue for an opportunity to try to open this discussion than here. The cornerstone of readiness for Army aviation is at Corpus Christi. So I thank General Munt and certainly Gail, thank you for this opportunity, as well as all of you. I look forward to actually getting out to the depot this afternoon. But one of the things that I often walk around and do the litmus test on is, what does the demographics look like? How are we bringing in those young enterprising minds that can help us think of doing things in ways we never considered or would have considered to date? So my offer is opportunities knocking. We just have to be willing to open the door and seize it. So thank you.
Good morning, everyone. On behalf of Colonel Jackson, the UHPO PM, I appreciate the opportunity to be here to talk a little bit about our Black Hawk fleet, talk about UH-60 Victor, and really the importance of CCAD and what it really means to our utility helicopter fleet. Those are the Chinook slides. Can we get the Black Hawk slides up, please?
That's Greg 48's plan.
So I'll just go ahead and start. So one of the challenges we have with the Black Hawk is we currently have 7 versions, configurations of Black Hawks out there in the fleet right now. So that becomes a challenge for us to maintain and sustain that fleet. We're currently taking action to divest our 60 Alpha aircraft and recapitalize our Lima aircraft into Victors. So we go from that big number of configurations down to 4. So in the end, we'll have UH-60 Mike, HH-60 Mike, UH-60 Victor, and UH-60 Victor with a medevac kit installed on that. So we have a plan laid out to support that that gets us there as soon as we possibly can. A large part of that is we are relying on CCAD to do the installations on those 60 Victor kits, and I'm going to talk about that in just a little bit if you go to the next chart. Almost one more. There we go. So it's definitely appropriate that for this forum that CCAD is the cornerstone of what we do, and that those words can be no more true, particularly for the UH-60 Victor. So we're not going to be able to field any aircraft to the fleet without our strong partnership with CCAD, because they are our production facility. We're not going back to an OEM to do that work. All those installations are going to be done right here. So really what 60 Victor does for Army aviation and for our warfighters, a couple of things. We are increasing situational awareness, and we're gaining a lot of value in the approach we're taking in doing that. So all we're really doing is just bringing a 60 Lima aircraft up to a 60 Mike pilot vehicle interface capability with some enhancements on top of that. So with the current economic environment that we are in, we are fiscally constrained. We have a lot of things we have to do. We've already talked about FVL, we've already talked about ITEP. Those have big price tags associated with them, yet we still have 60 Lima Blackhawks still with analog gauges in them. So while we would love to buy 60 mics and be pure fleeted, we just simply can't afford that. So that's really how 60 Victor came to be. So as we're doing this, I think we're doing some really innovative things to create a lot of value for our warfighters. Number one, we are integrating in a GADM capability. So we'll be able to, from the start, perform our RNAV, LPV approaches, et cetera. And we are doing that through what I like to what I talk about with this is a dual GPS architecture. So we still have we're still on a path to get to the M-coded Eagle EGI, and then we also have a secondary GPS system that is a commercial off-the-shelf Topstar 200 system. So what that really enables us to do is very quickly adapt in the future. I don't know what the next FAA requirement is going to be, but when it comes down the pike, I can assure you that I'm going to be the fastest platform to integrate that new capability and get it back out to our fleet, so we don't lag significantly behind the FAA. Back to the affordability piece here. We still have a lot of life left in these 60 Lima airframes. And we already know we get great value out of those aircraft. When they come out of CCAD, get back out to our fleet, we can track all of the performance parameters, FMC rates. We know that product going out is very good. We know we still have a lot of life left in those. So just doing a cockpit modification on that and sending it back out really gets us to where we need to be with a mic-like capability in a very affordable package. Additionally, with our pilot vehicle interface, we are not creating anything new. Yes, it is enhanced. There's some new functionality that's in there. But if you're going from a Mike model aircraft to a Victor model aircraft, it's going to be very similar to going from an Alpha model to a Lima. You're going to do a little bit of training at your unit. You're going to go out on a test flight, get checked off, and you're good to go. Now, the key there is you have to be Mike qualled, right, in order to get there. So that's something we're working with the National Guard on, make sure they are prepared to do the training. We're assisting there in a number of different ways. We know there's special requirements for the Guard to do those things. Specifically, how do we train that big volume? So we're doing unique things with IMI for maintainers, for pilots. So on any device, they can go in and refresh on how do I change out this part or this box? How do I do a startup or a shutdown on this aircraft? We're taking the Mike to Victor academics, and we're putting that online, so that can be conducted at the unit, at your home, on your phone, on your iPad, on a desktop, on a laptop. And those things will all be accessible at any time. So these are small things that we're doing to enhance the National Guard's ability to get the training and retain the knowledge that they need to be successful in their missions. A couple other things I'm just going to hit on from an innovation perspective, because it really is important that we continue to innovate as much as we can, because that value is really the result that we get out of that, and that's incredibly important. One of the things we're doing with our software on this platform is we're using model-based software. So instead of writing single lines of code, which can be fraught with errors, hard to test, hard to find an issue if you have one, what we're doing basically is with a model, you are basically constructing a wire diagram of inputs, outputs you want, making sure that all works. You push a button and the code just all comes out the other end. The code works. If the model is right, the code works. And in the civilian world, the FAA has already endorsed this. As a matter of fact, if you use CCAD software, the FAA doesn't really care about what that code output is. They don't go through and review that code, so we work very closely with AED to make sure they understand that and streamline how AED approves our software. Another thing with that model-based software that really allows us to do is integrate new capabilities. It's critically important because the speed of technology, the speed of our adversaries is getting faster and faster. Model-based software will allow us to integrate those new technologies very fast. So that is incredibly powerful. And then also from a cybersecurity perspective, again, we're able to integrate new functionality, new capability, and very fast in that model-based code. Next chart, please. Okay, so back to how we do business down here at CCAD. So this is just a general overview of what CCAD does for us. So we have a statement of work that we review on a regular basis. We're bringing the Lima model aircraft that comes into a Lot 30 baseline. We're just going to have 701D power. We're going to replace a number of depot level repairables. So when that aircraft goes out, it's going to be ready to fight. There's a number of things we're doing on the L2v Transition outside of the cockpit I just talked about. We're laying in all the wiring to support a 60 kVA generator when it becomes available and is required. Improved navigation sensors. We're pre-wiring FLIR video and power provisions, which is so important to our National Guard friends. Additionally, one other thing we're doing with this was the Missouri AvCrad is building a new wiring harness for us, nose to tail. That's going to really speed efficiency at CCAD. It's going to be really important for us. We're going to own the tech data package for that, which is going to allow us to integrate new capabilities at the wiring harness and get it down here. So if we know it's going to a National Guard unit, we know the National Guard wants all of these things and added on to their aircraft after they get to the unit, they're going to open up the panel and the wiring is just going to be there. All they have to do is plug it in. They don't have to tear apart the whole aircraft laying wiring. So it's going to reduce costs, increase efficiencies, and get the capabilities out there. Next chart. Okay, so I'll just caveat, this is a tentative schedule here, but we are really leaning forward in the Black Hawk project office. We're doing a lot of DMWR and work right now. We're doing a lot of engineering analysis to figure out exactly how we're going to recap 60 Mike aircraft, because we're planning on doing that here at CCAD as well. So we feel like we're ahead of the power curve here. You'll see ITEP integration on there. We're going to be starting that in the blink of an eye, doing that in the field, but then also our goal is to get those ITEP engines integrated in down here at CCAD when those aircraft come off during the recap process. We hit the 25-year economic useful life in FY32, and our goal is to start on those first 60 Mike aircraft at that time. Next chart. So this is just some detail again on our DMWR timeline, how we're getting from point A to point B. I'm not going to dwell too much on this chart other than just to reiterate we're leaning forward as much as we possibly can to make sure we're prepared to begin this work on time at CCAD. And that concludes my comments. Thank you.
Good afternoon, everybody. My name's Tim Sweeney, and I am the product support manager for Apache. And the first thing I wanted to go over is quickly explain to everyone what a product support manager is, because as I travel around, I find out that a lot of folks don't know. In 2008, there was a GAO study that determined that life cycle logistics and the costs were being traded off during the acquisition process. In an effort to fix that, Congress codified into law in 2010 the position of a product support manager. What I am chartered to do is make sure that the realm of the possible and the good ideas that the smart engineers come up with is actually supportable and sustainable at a reasonable cost. So that's what a product support manager does. So if you see that on a chart, that's actually what we're doing behind the scenes. As far as the Apache system, it's pretty much a hybrid. We have two performance-based logistics contracts. One of them with the airframe is done by Boeing. The other one, as far as sensors, is Lockheed Martin. And we also have some work done at CCAD. And one of the things that CCAD provides to us is the T701D engine. So you're a critical part of a remanufacturing line. As far as, well, let me back up. I was at a PMR last week, and our PM, Colonel Tal Shepard, came up with 3 priorities that I wanted to share with you, because how you frame a problem often determines what solution set you come up with. He said within Apache, we wanted to have people that were accountable, flexible, and ultimately reduce the soldier's burden. I mention that because through the preponderance of this conference, there's been lots of discussion on the supply chain, and the supply chain is a very important piece of that. However, maybe issuing an individual component is not actually reducing the burden on the soldier, and maybe we'd be better off if we send an entire assembly. So things like that is what we're trying to look at to ensure that we minimize the times that the soldier have to work on an aircraft, also looking at readiness and reliability data. Go ahead, go to the next chart. One back. All right. As far as the CCAD components, the charts that I have basically just list the workload that's coming to you. The workload's relatively stable. There's not any big surprises in it. And it states what I said. Go to the next chart. Can you go to the next chart? Yeah, it's not working. You can go to the last one. I figured that those charts may provide value to you because they're being released, and that way you would know what workload that we're planning on providing to the depot. Go to the last one. All right. Currently, right now, we don't see much fluctuation in the current workload. As far as the performance to promise, one of the things, since we're in a just-in-time environment, that we're looking at is we want to make sure that, as Mr. Marriott showed you, you have that on that one chart where you had the blue and the yellow and the amount of time that it took for us to get healthy and get that strategic depth on the stock. That's why the item managers are so, I guess, adamant about the performance to promise, because that affects that metric, and they want to make sure that they can get to that strategic depth as quickly as possible. As far as CCAD workload, I will once again say that, how problems are defined at the point often determine the solution path that we go ahead, that we march on forward with. Performance-based logistics was done at the time where the DOD was looking to get the biggest bang for their buck. So performance-based logistics generally is cheaper. Of course, you trade off some of the redundancy that currently the current leadership is looking for. But and a lot of the reason why it's cheaper, to be perfectly honest with you, is the inefficiencies located within the normal distribution supply chain that we have, because the number of assets required to fill that pipeline is significantly higher than what a corporate company can do and sustain the fleet. So what I will tell you is reducing soldier burden is what we're focused on in Apache, and we've empowered everyone across the organization within the chain to come up with some ideas. Just because we haven't done it in the past, it's not the right point forward. I think Colonel Clark kind of hit the nail on the head. The way we did business before isn't necessarily the way that we need to do business in the future, and we need to be open to changes to assure that we can all get to where we need to go. That's it.
We're open to your questions.
All right, while they're thinking, let's talk across the board. The ITEP engine is designed, built. There's a lot of controversy about it, but in fact, it was originally designed to replace the T-700D in the Apache and in the Black Hawk, okay? And then there was a point somewhere where we said it's going to be the FVL engine. And clearly, FARA now has that as one of the requirements, as it states it, that FARA, the Future Attack Reconnaissance Aircraft, will do that. So, but that wasn't in the planning process for ITEP, nor do the timelines between ITEP and FARA happen to match. And then the third point would be Cape Set 3 right now, the way the requirements have been written and done, that engine is not large enough to support the size of aircraft that right now is in the books. So they're closer to being a CH-53K or a CH-47 vice a Black Hawk or an Apache or a Cobra or a Huey that they were designed to replace. So how would you address that?
You want me to take that one, or you want?
We can certainly jointly look at, from my view, reference the ITEP specification under the FAR competitive prototype. I think we're on. I think that was another opportunity. The shaft horsepower requirements that were envisioned for that class category of vehicle and what we understand of the configurations, the competitive configurations, to me, there was an opportunity there for an economy of effort type of a solution. Certainly, I think we would all appreciate that reducing that sustainment tail is always a goal. If Army Aviation could reduce the number of engines across its portfolio, that could be a good thing, so long as we're not compromising good design. Right? So there's always that marriage there. So I see Cape Set 1 as opportunity presented itself, and we wanted to leverage that. Reference Cape Set 3, still very early in requirements derivation. Analysis of alternatives is ongoing, should complete around third quarter of 19. The different configurations, given that class of aircraft, have different shaft horsepower requirements. Still unknown. We are remaining eyes wide open to what those power requirements will be. As most within the industry here should know, we released an RFI recently specific to, in coordination with ATE, on a Cape Set 3 engine, just to see what's industry doing to innovate in this area, to help inform us. So we're looking very forward to that information coming back to us. We've already seen some, and we're pleased with the number of respondents to date. Scott, I don't know if you want to.
I think you hit on the key, sir. So one of the things we're looking at is this, combination of not trading off requirements for power, that matches to airframes, but can we get to a minimized classifications of engines in order to meet our future fleet requirements? And I don't think that's much different than, the other services within DoD of looking at commonality across platforms. And if we can get to 2 to 3 power classifications in the future and design towards that, and understand what those trades are, then we can start to make some decisions. And so that's what the RFI for the Capability Set 3 power was really, kind of focused on, is whether it can meet multiple platform capabilities. And the same thing with the baseline for the program for ITEP was the UH-60 Mike, the AH-64 Echo. There was the opportunity of bridging that and providing that capability of 60 Victor, and now we recognize that there may be a power classification commonality there that allows it to be the FARA engine, and we want to at least entertain that investigation along the entire road.
I'm interested in, maybe it's more of an advice question from you guys. I'm interested in where you think you see risk or even more importantly opportunity as it relates to life cycle management and sustainment as we transition to Army Futures Command. So I think Andy's slide relating to the number of mission design series aircraft you have to manage certainly translates to us as a configure management complex nightmare to some degree. And there's a lot of intersections in there between building new and sustaining old and where those lines blur. I'm interested if you have any concerns or you see opportunities with the standing up of Army Futures Command as it relates to AMC's ability to see that, affect it, and make sure that we remain completely integrated.
I think, once again, since you're the closest to relating to CFTs and that link.
Challenging question. And we have opposite ends of the spectrum at work. There is a desire for commonality and reduction in configurations that would be, I think, universally accepted. But there's also the recognition that to be a threat-based Army, in terms of its material development, you have to remain very agile. I think we will find ourselves looking more transition away from mitigation to adaptation. The configuration management challenges, I believe, will always be present within Army aviation, especially if we're in this very rapid cycle of developments and the agility that Army Futures Command envisions. I think it's the challenge for us as an industry is how do we adapt to that, to where it's not so cumbersome, to where we have that asset visibility. Would be more where I would focus my efforts than in trying to figure out how do I continue to reduce the number of variants. That's just my personal opinion, because to stay up with the threat, and if we're to seize technology and to do it in these innovative prototyping methodologies, we could find ourselves with more variants in the field, or more configurations maybe. I don't think we'll see the difference between, even we see it somewhat in Apache between the blocking mechanisms. We still very much look at incremental developments. Other services do look at it different. Some would prefer to have a full step to their developmental cycle because they may feel that they only get one bite at the apple or one opportunity to field a new capability. My understanding of Army aviation is we very much have adopted the incremental approach. I think that's, in my opinion, allows us to be more agile within the funding cycle that is presented to us, as well as responding to the threat. So I don't have a great answer, but I do think we're going to be faced with this challenge throughout the future.
Okay, well, listen, we are right on time. I thank the panel, again, Scott and the panel. An amazing dialogue, so I'd ask for a round of applause.